I need to stop doing that little tick at the beginning. Hello and welcome to the chi-squared edition of Fun Times with Minitab and Statistics. So I'm hoping you noticed today that I have Express open instead of Minitab 17. I'm going to show you how to do this on both versions. Unfortunately, I can't open the data file twice. So like I I tried doing this earlier where I would open it in 17 and Express at the same time and do stuff, and it will not let me do that. So unfortunately, I'm gonna have to do two videos of this. So if you watch this one and then watch the next one, you can skip through the parts where I'm describing the hypotheses and reading the question and all of that. So fun times. All right, so let's read the question so we can get started. A subtle form of racial discrimination in housing is called racial steering. Racial steering occurs when real estate agents show prospective buyers only homes in neighborhoods already dominated by that family's current race. Tenants of larger apartment complexes have decided to file a lawsuit alleging racial steering. The complex is divided into two parts, Section A and Section B, and tenants suspect that the white potential renters were steered into Section A, and while black potential renters were steered into Section B. Minitab worksheet racial steering MTW, I can't believe I just read that like that, contains data from a random sample of potential new renters that visited the complex. Perform a test to detect if there was evidence of racial steering. So what we're looking for here is we're looking to see is there an implication here that these two ideas of which section they were visited or they went to is related to race. I'm really asking, are these two related to each other? So our null for this is I think these are independent, and our alternative is going to be I think they're not independent. I think there is a relationship here. And remember, the chi-square test assumes independence. It's one of the requirements to perform the test, and that's why the null, the baseline of what we're going to start with, is going to be independence. But I'm going to write this two different ways. Well, I'm going to write it one way and then write things next to it. So what we're trying to measure here is something that will actually answer the question. And that's the idea is that, there is no relationship between race, I want to capitalize this since it's clearly a variable, and section. So AKA, we're talking about these are independent. So the idea of independence can be the same as saying these two are not related. That's what I'm trying to say by this null hypothesis. So be thinking, if I'm thinking about this as relationships, that's how this is going. So my alternative is going to be that they're not independent, which means, oh, if they're not independent, they depend on each other and there must be some relationship between the variables. And this is what the investigator is suspecting. He suspects that there is some racial steering that has occurred. And that's why that's the research or alternative hypothesis. Okay, so the first thing we're going to have to do is create a count table or a two-way table of the observed counts that, you have for the start, because I have raw data here. I have the person's race and what section they were visiting. So I would have to fill this in. Now, if your data is really, really large, you don't want to count this by hand. So we really don't want to do that. And in Minitab 17, you would do this separately, but in, these two parts, the observed and the expected. But in Express, we actually do them all at once. So, and I'm going to actually have it do the chi-square and everything all at the same time. So once you reach the idea of I want it for observed expecteds or chi or any of that stuff, you can go ahead and hop over to Express. I'm going to have to lose my Word document for a minute just because my screen is not large enough for me to have both up at the same time and be able to access the things I need to access on Express. So let's click over here. The problem is that if I shrink this, you notice I lose some things and my menu gets smaller and you can't always get to the ones, well, I can't really, well, this one I can still get to tables, but difficult things happen. Anyway. So what I really want is I want the cross tabulation chi-squared. This is how I can create a two-way table or a cross tabulation. That's the other name of it. So it first asks me what I want as my rows and my columns. Well, hold on, let's look back at the Word document. It appears I have race on the columns and section as my rows. So I'm going to put section in as my rows. And then my column is going to be race counts. So as you look at this, this is raw data categorical variables. If you drop down this menu, oh good, more yawns, more coffee needed. There's also summarized data in a two-way table. That's if you had a two-way table, so something that looked like this but was already filled in with numbers. You could actually write that into minitab express and then use that instead, and you have to indicate like where this is and where the counts are and everything. Um, so there's that. Um, so I'm going to now click on display. Display gives me all the options I need in order to perform a chi-square test. So the first thing it's going to ask me is, do you want some percents? I don't really want percents, but I do want expected count cells because that's going to give me the expected values for each. And I also wanted to do the chi-square test for association because that'll complete the last couple parts where it's asking about p-values and chi-square values for the remaining steps for this question. Let's go ahead and hit OK. I'm going to scroll this down. Okay, so cell contents. This is a little where this gets hard to read. So as you look at this, one cell would be right here. That's black and A. And then as you look at this, the content of one cell is count and expected count. So I'm going to pop up my Word document and fill in the answers. So black for A is 8 for the actual count. White, it's 87. That's already looking pretty suspicious. 34, and then 83, and I'm hoping you're seeing how I'm picking these off. And then for the expected counts, those are the lower values. So counts on top, expected's on bottom. So black A will be 18.82. For white and A, it'll be 76.18. And it does round this quite a bit. So if you don't want to round these, you should calculate them by hand. 93. Watching me type is so much fun, isn't it? Not really. Okay, there we go. The next thing I'm going to need is the actual chi-square test, which it's giving to me right here. We actually do the Pearson test. So, oh God, where's my Word document? There we go. So what I want to use is the, come on, the likelihood ratio is just a different type of test. It's not the one we are using in particular. Ours is going to be the Pearson one. It's just a different type. So our chi-square test statistic would be 14.04. Make that purple, make it a little bit bigger. And then it asks you for how many degrees of freedom you had, and I'm hoping you look at this and you're like, it's a 2 by 2. I subtract 1 from each of those and I get a 1 by 1, so this is definitely a 1. Or you can totally cheat and look and see that it's right there. And then last but not leastly, hey, we should find the p-value. Yay, it's right there. 0.00. Wait, one more 0, and then a 2. I have a little bit too much fun with this. It's probably a little obnoxious for those of you listening. Okay, so we found our p-value. Now you might look at this and be like, I don't know, that seems like a little bit, I don't know, not accurate enough. I want to know more. So if that's the case, there's ways you can actually get a little bit more of an accurate p-value since you know the chi-square and you know the degrees of freedom. Let me show you how you do that. So if you go up to distribution plot and then go to display probability. So again, I'm at distribution plot, display probability. Woohoo! It gives you the option of, hey, you want to do a normal one, right? No, I'm doing a chi-squared, so I need the chi distribution. Dink. And then it immediately asks you for your degrees of freedom, which ours is 1. And then I want to do an x value, and I want to do a right tail because the chi-square test is always a right tail test. And then I'm going to put in my chi-square test statistic because that will be the border of my chi value. And now we're going to hit OK, and it's going to produce a graph for you that will have a little bit more of an accurate probability for you. Oh, it's so tiny! But it's a little bit more accurate than 0.00002. So if you're asked a question in your homework where they want more details or more decimal places, this is a way for you to get it. The graph actually usually doesn't round it as much as the test itself, which is a little strange, but there you go. So if you need it, there's the graph to get it a little more accurately. You don't have to do this. It's just if you're dealing with something that's really, really tiny, like engine parts, small probabilities or small measurements really, really, really matter, and then you should make sure that you're a little more accurate than, you know, this. It's the rounded one. Where is it? That guy. Super, super tiny. Anyway. Okay, let's state our conclusion. Okay, super tiny p. We know what's going on here, right? Well, yeah, we're going to reject. Oh, God, I sound more and more unintelligent the older I get. Because I'm like, look at me, I'm so hip. Reject. But that's what we wanted. We suspected they were, well, it's not necessarily what we wanted. We don't want racial steering. It's just that, that's what we are appearing to see. Aha! The evidence suggests that racial steering is present between in. So really, what you should say is, oh, it appears race and section of housing were related for this apartment complex. And that's what the evidence is suggesting. They are related. However, that really doesn't answer the question. Was it racial steering? It looks like it because it looks like these two related. And I'm going to elaborate on that in a minute. So the evidence suggests that racial steering is present in this apartment complex. Since race and section appear to be related. Okay, so a couple things. I am being specific about which population this represents, the apartment complex, not all apartment complexes. Be careful about this. This is a really common mistake with statistics, to take your sample and try to use it to say things about a different population than what you're currently looking at. Since we're only looking at one apartment complex, not many apartment complexes, we can only say that this represents the one that it came from, which would be that one specific one that had two sections, A and B. Okay. Next, we are going to do a goodness of fit test. Sorry, I paused it briefly so I could type these into Express so we weren't wasting time on watching me type again. I should do that every time. Anyway, so we need to come up with some stuff. Oh, I haven't read this question yet, have I? Okay. All right, let's do this. All right. A real estate agent located in a metropolitan area in the northeastern United States kept data on various types of properties purchased in the area. Historically, 15% of purchases were for condominiums, 30% were townhomes, 40% were single-family homes, 10% were commercial properties, and 5% were for land. With changing demographics, the agency was wondering if the current distribution matches the historical distribution. Recent data shows the following counts. So you're given the type and the frequency for the area, I'm assuming. You really shouldn't try to take other areas of the country and compare them to each other because certain parts are more rural than others and more vacant than others. So, yeah. All right. So this is a goodness of fit test because you have one variable, the type of property, and you're comparing it to historical values or some other value. So you're asking, are these distributions the same? This is a goodness of fit test. So your null hypothesis is that, hey, the current values are always the same, or nothing has changed. It's the status quo. So we'd say the current distribution of properties, property sales, because that's what we're looking at as sales, matches the historical one. Sorry, I had a brain fart on how to spell historical. I'm still having a hard time with it. There we go. It's literally up above. Why don't I just cheat? I don't know. Because it's not a bad thing to challenge your mind. It's saying they're the same. Remember, nulls are always about equality. They're about the status quo. It's about, well, I haven't seen any differences. Okay. So our alternative is that, hey, we think things have changed. So it's not that they match, but now they differ. So differs from historical distribution. All right. So it's like, hey, what's the p-value? What's your conclusion? Do some things for me. Okay. Now we need to pull out some chi-e goodness to get this going. All right. So clicky over to our data and things in Express. So like I said, I typed this in ahead of time. That's why I paused, so that you could see this easier and not have to watch me type. Anyway, so notice right next to cross tabulation and chi-squared is the goodness of fit. That's the one I'm doing. All right, let's do it. Yeah, thanks. Okay. Now, if you have something like this where it's summarized counts in a table, you don't want to use data in column. That's as if it looked like something like this, where it was like A, B, C, C, D, C, C, D, D, D. Or if you had something that said like condo, 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 townhouse, home, 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 it was a list of the variables, not counts. So since I already have counts, this is actually summarized data. I should use summarized data. Okay, and then it asked me, where are my observed counts? Well, those are in the frequency column. And then my category names are in the type column. And here's where I want you to be careful. You're going to be tempted at some point when you look at raw data that looks like this, because this is a frequent way in which newspapers and other articles will organize data, and think to yourself, shouldn't this be going across? Because, this is going across. Shouldn't Minitab be doing the same thing? No, Minitab reads variables by column, so you really need to organize everything by columns, not row. Anyway. The only exception being if you're doing cross tabulation and you have summarized data, but that's a whole other ballgame. Anyway, so the next thing we have to do is we have to tell it the type of test. So if I was assuming that all of my types, condo, townhome, home, commercial, and land, were all equally represented, then I would be okay to hit OK because I have equal proportions as my test I'm doing. But that's not what I'm actually doing. Go ahead and drop that down. And you'll see some options. There's proportions based on historical counts and specific proportions. I want to put in specified proportions because I want to be able to type in the ones I've got to match the types that I have, which is why I put in the optional value of what type it was. That way I can match them up like this. So commercial, reading back into the document from before, how much was commercial? 10%. So I'm going to put in 10%, 0.10. And then condos was 15%, 0.15. See if it'll make another 0 for me. Oh, it did. And then homes was 0.40. Land, it organized this for me in a weird way, 5%. And then townhomes. Oh, it alphabetized it. That's why it doesn't match this. Minitab, you stinker. Ugh. That's kind of annoying because now I'm like doing this very slowly because I'm having to go back, looking back and forth at the print off of this question to make sure I have these right. So I should double check these. 15 were condos, 30% were townhomes, 40% single family, 15% condominiums, and 5% land. Okay, this looks good. Let's go to the display options. So, bar chart of reserved count versus expected. If you needed a graph to represent how different these look, that's a great thing to leave checked. A bar chart of each category's contribution to the chi-square value. I actually don't use this one that much. This is great if you're trying to figure out which grouping appears to be behaving the most differently, which, depends on what you're looking to use this for. If you're looking just to say, are they different? That's what you don't really need this. If you're looking to say which one is the most different or which one is the most changed over time, you definitely should ask for this. So it's ordered from largest to smallest. I'm going to leave this checked so we can talk about it. Let's go ahead and hit OK. Where's my graphs? Where's my graphs? There they are. Okay, sorry. So the first thing I'm going to do is I'm going to steal my p-value off of here. It's less than 0.0001. So, yeah, I'm just going to type that for now. I don't really like that answer. That is not the less than symbol. Good job, teacher. All right. And, when it says stuff like this, usually what I do if I'm the reporter of this information, I always list the chi-square value as well, just because it makes it a little clearer just on why this is so small. And that's because the chi-squared is huge. And if you wanted an exact value, which I think I'm going to do real quick, you would go ahead and do the graph thing, the distribution plot like we had done before. So since my degrees of freedom is 4 and my chi is 62.54. I'm writing these down really quick because they're about, I could just move this over. Why am I doing things? Okay, so again, I went to distribution plot, view probability. We're going to go down, or go up rather, to the chi-square. I thought it would be on the chi-square because I just had it and put in my 4 for my degrees of freedom. X value, I got to do a right tail, and I'm doing 62.54. Hit OK. This is going to give me a more accurate view of the probability. Oh, it's that tiny! Okay, it's not only smaller than 0.00001, it's smaller than 0.0000000. I think I did enough zeros. It's super small. I would call this 0. Anyway, so there's that. So if you wanted a more detailed chi value, there you go. It's so tiny, there's no questioning it. So let me write my conclusion real quick since we're on that, and then I will go back to analyzing the graphs for a second. So, okay. So small that it looks like 0. So we are definitely going to reject, which is great and everything, but I need to actually say what's going on. There is very strong evidence that the current distribution of properties, sales, differs from the historical distribution. And I never use the word vary because I feel like it's a waste nonsense word. Clearly it's strong. Duh. I mean, vary is like, I need to make a word count word. It's a waste of everyone's time. What's a better word than very strong? Epic? I don't know. Whatever. The point is, all you're able to say is, hey, they appear to be different. Now, if you want to say specifically how different, that's where we need those graphs. So I'm going to go back to the chi-square goodness of fit test. And so if you look here, it's telling you the contributions to chi. Look for the largest ones. Homes and condo sales are the two largest. That means these are the greatest contributors to change, or the ones that have changed the most dramatically. Another way you can see that is if you look at the expected value versus the observed values historically. So if you look at this, one of the things you can say is that, oh, well, these two are super, super far apart from where they used to be. The condo sales is much higher than what you expected, and the home sales is much lower than expected, and the townhome sale is actually much higher than expected. So that's where you're seeing the greatest amount of change, with condos being the most severe and homes being a very close second. So if you wanted to see that in a graph, here you go. Oh, you can't see that all in one view with my terrible laptop. Okay. So look, these have stayed about the same, these stayed about the same, and then look at the change in condos. This stayed about the same, and then you had a huge change in the other direction in homes. So in looking at this, you would be able to say the greatest change occurred in condos and homes. Townhouses, commercials, and land stayed about consistent, but these two had a huge difference from historical values. So that's how you do some chi-square action using minitab. Remember, when it comes to the test for association versus independence and homogeneity, it's the exact same test. It's just your hypotheses that change. So don't think just because I only did one of the two that you're missing out, because you're totally not. That's all I have for you today, and that's it. Remember, chi, not chai. Chai is a T and has an A in it.